Please give a big welcome, Martin Costello.
Hi everyone. So I'm Martin Costello. I'm a principal engineer at justeattakeaway.com and socials. So I'm going to do a talk today about some of the things that are new in .NET 8 because there are a lot of things. So what's on the menu of what I'm going to try and fit into my 45-minute slot? It might run over. It might go under. Who knows? So I'm going to talk about what's the point of .NET 8, or maybe not what's the point. What's in it? What's the idea? What's some of the themes behind what's in .NET 8? Because every release of .NET seems to have a theme these days. Then I'm going to do a very high-level sweep through some of the new things. They're just going to be me saying a term and saying roughly what it is, and then moving on. And then once we've got through that, I'm going to go into two new features of C# 12. I'm going to go into some of the new APIs that are in the BCL. Then I'm going to do a tiny little interlude on AOT, because that sets up the final set of things. No, they're not the final set of things, sorry. The next set of things, which is two new source generators. And then finally, if there's time, I'll cover two features in the SDK, which are just like developer improvements. So what is .NET 8? So .NET 8 is the next major release of .NET. It was released last week on the Tuesday, as like Dylan said. What is now the annual day that a new stable version of .NET drops. There's previews for months in advance before that happens. I'm a bit weird. I've been using the previews since we got preview 2. I usually avoid preview 1 because there's usually nothing new in it. And it's the latest long-term support release. So if you're not familiar, there's LTS releases and STS releases, which are now short-term support. So long-term support, once you install it, as long as you keep patched, you're supported for 3 years. But if you use a short-term support, you're only valid for 18 months. And there's like an overlap window between the two. But with it, .NET 8 being the latest LTS release, that means that the end-of-life support countdown started on all of the other currently supported releases of .NET 8. So if you're running .NET 7 to stay supported, you've got until next May to update to 8. But if you're on .NET 6, you've got until November next year. And this is taken from the .NET support policy website. So you can see there's like lots of overlap on there. So if you say you're running .NET 6, you had 2 years of just keeping up to date, and then .NET 8 came and it was like, right, now you need to upgrade. But you've got a year to do that, because when .NET 9 arrives, that's basically when everything stops. So what are some of the themes of the .NET 8 release? So there's a good website that the .NET team themselves use to do all their planning, because for whatever reason, even though they own GitHub, apparently it's not good enough to do their release planning, so they've built their own on top of it. So themes of .NET, which is one of many of .NET domains that the team owns. So one of the things that they were doing a big push on for .NET 8 was AOT support. So AOT is sort of becoming one of the new hotnesses. And part of that's because a lot of people are moving to containers and infrastructure, and like all those bytes add up. So like you go, oh, I've just got containers, it all spins up really fast, that's great. But when you want a new container, it still needs to pull the container down from the registry. And the bigger your container image is, the more there is to pull down. And then once it's pulled it down, the more your app does on startup, the slower it takes for your instance or your container to actually go into service and start doing useful things. So AOT is one of several ways to sort of chip away at that and get your startup times down to as short as they can be, so that you can scale even more on demand than maybe you did, say, 10 years ago with a big chunky EC2 instance. So that fits in with their cloud native theme. There's also JS front ends with .NET backends and MAUI. I don't go anywhere near those things, so I'm not going to talk about them in any shape or form other than say they were part of the release and one of the many things that the huge .NET team worked on. There was also some NuGet stuff, which I'm also not going to cover. So what's actually new in .NET 8? So I'm going to rattle through this list fairly quickly. So there was C# 12. The runtime added a bunch of new APIs, new types. If you're into your JSON stuff, but you don't like Pascal or Camel Case, then they came to the rescue and they brought Snake and Kebab Case for you. There's a new time abstraction called Time Provider. The stuff I've highlighted in orange is the stuff I'm going to be talking about in more depth. There was Frozen Collections, which is like more optimized ways of doing immutable data structures. There was loads of new vectory stuff for machine learning and stuff like that. I don't understand all of that stuff, but they've got even more bits now. For security stuff, SHA-3 support, key DI services for dependency injection. In a nutshell, that's like if you've got multiple interfaces of the same type, but one's for that thing and one's for that thing, you used to have to like build custom code on top of it at the time of resolution to decide which one to do. Instead, you can now do it through keys. So I don't know, if you've got a database per country, your key could be the country code. And then you can just put an attribute on your DI resolution and you just go, oh, I want the UK one of that. And then it will do all the magic underneath to sort that out for you. There's also a source generator that I'm not going to talk about, which is about options validation. So if you've got your strongly typed options, it can do source gen to like validate that all the things you said were required are there and the regexes are matched and ranges and anything else you might have. There's also some abstractions to do with meters, which sort of fits into like the big push to like open telemetry, all of that observability goodness. And then native AOT. Native AOT existed before, but the number of use cases that applies to it has expanded now. I don't have a Mac. Dylan does. It's running everything off him. But AOT didn't used to be supported on Mac. So if you have a Mac and you update to .NET 8, you can do native AOT on your local machine now. And there's also dials in native AOT as well, because it used to be that you just got the set of optimizations that the .NET team thought you should have, but now you can sort of toggle between I want something really small and I want something really performant, and you can sort of adjust the dial in between the two to have whichever one meets your needs. Whole bunch of extra stuff for the SDK. You can now use the SDK to sort of query for MS build stuff. So if you need to know what the value of a property somewhere in the build system is, you can just query the SDK now and it'll work it out for you. I'm sure that'll be useful. I haven't used it myself because I haven't yet hit a rake or stepped on something where that was useful. There's a new terminal build output feature, which we'll come to later, which improves the developer experience for when you're locally trying to get it to compile and it won't, and what's going on? Simplified output paths. If you've got a complicated build system that builds lots of things, this makes it a lot easier to find stuff. And we'll cover that. There's also things to clean workloads. A nice little feature is they've changed the default. So now when you do .NET Pack, .NET Publish, it does it for release by default. It used to do it for debug, which I'm sure has caused plenty of developer pain in the past of wondering why everything's running so slowly. Oh, I deployed the debug build. Containers. The default container image for .NET 8 now is Debian 12 Bookworm. You can also run as the non-root user now. They've done lots of changes in the setup for that, so it's more secure by default. It's like if someone somehow gets a foothold in your container, it's good to not have them be root, because then who knows what they're going to do after that. Also, some default ports have been changed, which is a fallout of that, because .NET now runs on non-privileged ports by default, which enables the non-rootness. Some Blazor stuff. Some improvements to minimal APIs, so they've made some tweaks to support form binding use cases. And then in support of that, there's now anti-forgery security features sort of built into it now, because before it was easy for you to go to minimal APIs and then accidentally open yourself up to CSRF vulnerabilities if you didn't manually check for things. So that's now built in automatically. A subset of ASP.NET Core now supports AOT, and we're going to go to touch on those in a bit. And there's also loads of built-in metrics now in the hosting and Kestrel and SignalR. So if you're using OpenTelemetry and whatever the expensive thing you buy on top of that to see what's happening, there's more metrics built into it now, so there's less you have to instrument in your own application code. And then I've just put it on there because they made a big deal out of it. There's also .NET Aspire that was announced last week. It's a whole suite of libraries and local development experiences that build on top of all of this to try and make it easier to run distributed systems. But that's a whole topic in of itself, and I'm not going to be talking about .NET Aspire otherwise. So yeah, there's a lot in .NET 8, and I'd probably be here all today and tomorrow, even if I understood it all, to talk about it all. So now we're going to touch on to C# 12, and I'm going to cover 2 new features. These are all the new features, or at least that are in the high-level summary that were added in C# 12. So there's primary constructors, there's collection expressions, ref read-only parameters, which is a variant on the in keyword, inline arrays, which is like a hyper-performance optimization for when you need to do stuff with arrays. You can now alias any type. This seems to mainly benefit, or at least on my skim reading, when you're doing unsafe code and you want to like alias pointers and things. You didn't used to be able to do that, and you can now also alias tuples or tuples. Still don't know what the right way to pronounce that word is. There's also
Because there's 2 of them. There's 3 of them, that's a triple. That's what I
sold.
Yeah.
There's also an experimental attribute. So there's a new attribute you can put on an assembly method, whatever, and that will cascade up through the build system. So if you've got an API that you want people to try out, but you don't want to take any support burden on, just whack an attribute on it and go, told you. And then there's also a new feature called interceptors, which I'm not going to go into specifically, but is related to something we'll talk about later when we go into some of the source generators. So we're going to have a look at primary constructors and collection expressions, and now this is when I need to switch to Visual Studio for a live demo. So this is when it all goes wrong. So what have I opened first? Collection expressions. So collection expressions is a new, more succinct syntax for when you want to do something with collections, not just arrays. It works with lots of different types. If you're familiar with JavaScript or TypeScript, I think, how do I declare an array in JavaScript? Well, spoilers, it's going to look a lot like this. So I'm just going to skim through this, and I've got a few different use cases that I'm just going to point out to you. So the first thing here is, like, even though the syntax is the same, the compiler will know, based on the type of your variable that you've declared, what type to actually make. So this expression here is literally an expression. It's not sugar on new array. It's I want a new collection of stuff, and the compiler's got lots of heuristics baked into it to do the right thing for you. So in this case, because this is an array, this will be an array. Similarly, if I assign to a list, it will create me a list. It will also do the right thing based on a method call. So I've got 2 methods here: print values that takes an IEnumerable, and print numbers that takes an IEnumerable here. But can't remember. Yeah, I forgot why I pointed that out then. So what's happening here is, because it's an IEnumerable, the best type that the compiler can give you in terms of like performance and sort of trade-offs is an array. So even though it's in an IEnumerable, the compiler knows that if it gives you an empty array, that satisfies that contract. So that's the type you'll get there, even though you might go, well, how do I do that? Because it's a bit different to, say, target type new, where you can just new any type, but that doesn't work with interfaces, because it's like, well, what interface does that map to? But in the case of collection expressions, it can pick lots of different options to sort of give you the right thing. However, that falls down if you have a type parameter, because it doesn't know what type. So in that case, in this case, print values, because I've given it some numbers, it can infer their arrays and give me an integer array. But in the case where it's empty, it doesn't know what the type is, so you have to specifically give it the type hint there. Also, when you use a different type, the compiler will change what type it's going to use so that the use cases fit. So in this case, I've got a method called add to collection and print. It's a ronseal method. It does what you think it does. But because it's taking an iCollection, because iCollection has an add method, while an array implements iCollection, arrays are read-only, so you can't just add more things to it. So it would be a bit surprising for the compiler to then give you an array and then your code throw an exception because it can't add any items to your array. So in this case, it will give you a list, and then it sort of conforms to the contract, and then you could add something. Then similarly, for if you're familiar with JavaScript and TypeScript, I mean, they're similar. One's a subset of the other. You can now use the spread operator. So in this case, I've got my array and I've got my list. If I use the spread operator, which is 2 dots, I can put those inside a collection, and it will create a collection for me that contains everything that was in the first one, so all of the items in the array, and then all of the items that was in the second one, which is the list. But you can also put literals into that expression as well. So in this case, I can put other elements in between those collections. And then, just because I can, you can also use it with the slice syntax that already existed. So what I am going to do now in advance of, I should have put the right folder open. Excuse me. I just need to run this because it has a runtime demo bit. It's not a demo without a typo in a shell.
That's how we know it's live, right?
Sure. So that's set me up. So yeah, just to go back, so we can see here like all the different examples. I've just written some boilerplate code that prints the types and what you think it's going. So in the case of an array, you get an array, list, enumerable. You get this unspeakable name to a special magic empty array that lives somewhere. Empty array, array, enumerable, array, collection, list, so that I can add to it. And then for my spreads and my slices, I get the same weird unspeakable name again because optimizations are happening under the hood that I don't need to worry my pretty little head about. Or at least not in most cases. So then back to Visual Studio for a second. So the other smart thing with collection expressions is it will also make the right type for you based on the call syntax. So I've added a load of methods here with all different parameter types, but you see what I'm doing with the methods looks exactly the same. They're all square brace, 1, 2, 3, square brace. They're all exactly the same. But if we print out the types at runtime, we've got an integer array, we've got a blocking collection, we've got a collection, we've got a concurrent bag, we've got a hash set, immutable array, list, span, read-only span, you name it, the compiler, it's essentially doing duck typing. If it looks like one of them, I will make one of them for you. It can also specialize for the read-only versions of the interfaces. So if we've got a read-only collection or a read-only list, then I will get a read-only variant of it. But if it's not read-only, then it will just give me a list. It also works for custom types, which I think is the more cool thing that was slightly mind-blowing for me. Where's some numbers gone? I've lost my own, there we go. So I've made a custom type called some numbers, it just inherits from list, and I can't defeat the compiler by going, nope, sorry, that's not built-in type, you can't use that. It just goes, well, it's just one of them, I'll just make you that type. So it creates the sum numbers for me, even though that's not something that the compiler ahead of time can special case. Also, they were planning on adding support for this with dictionaries. It didn't make it in, apart from the surprisingly specific use case of empty dictionaries. If you want an empty dictionary, you can also use square brace, and that also works with custom types. So I've created a derived type called crew members of dictionary, and then there's the leftover example that I was going to use until I found out it hadn't made the release and it didn't actually work. But I'm glad I didn't waste too much time trying to work out why isn't my code working. So that's, yeah, I'm done with the live bit, the .NET run. So that's collection expressions. So now we're going to nip through to the next one I've got, which is primary constructors. So primary constructors, effectively, they lift the parameters from your constructor from a constructor and put them onto the type. And the way I think of them is I weirdly visualize code in a slightly 3D way, because like when you've got like a lambda closure and you've got like your closure and your capturing state, I sort of like think of it with Z index, even though I'm rubbish at CSS. So it's like you're moving the constructor back a level to the type level. So to give an example of that, so I've got a type called person11. It's got a constructor parameter, takes a name, assigns it to a property, and then I have a derived class of person, which is a presenter. I'm sure this is all very familiar to you. Here's my constructor, I call the base class, I pass in parameters, etc., etc., etc. But with primary constructors in C# 12, it gets a lot more succinct. So in the case of the person class, I just put the constructor parameters on the class declaration, and the compiler is effectively synthesizing a constructor for you and creating the variables. And then, like with a lambda function, that's now in scope for the whole class body, and you can use it where you might want to assign stuff where you would do things in the constructor. So in this case, the name parameter here is from the constructor you can't see, and that assigns to the name property. But then if I want to do a derived class, it's kind of the same. So I just start passing parameters to the type I'm inheriting from, which might look a bit weird, but it's effectively you hoist them all up and they're declared in the same way. In the case that you have multiple constructors, you can still add additional overloads like you could before. The only quirk, well, maybe not quirk, design decision is that you always have to call the primary constructor. You can't have one of those constructors where one does something and changes some state and one does something else and changes some state. They always effectively, you have to do like and then this, or base sort of construct. And then you can still capture the state, and you can also mutate the state. So the compiler's effect, in the case here, because if we call the present method, it changes is presenting to true, and is presenting is one of the constructor methods. So the compiler will synthesize a field. Well, it was doing that anyway, but the field is synthesized, is not read-only, so you can change the state. I personally wouldn't recommend adopting this syntax in complicated code where you need to do lots of things in constructors or you've got lots of variables, because it might start to get hard to reason about the scopes and the lifetimes and things. But for things like test code and simple POCOs, I think this is really useful because it can turn like a 20-line class into like a 5-line class. I'm sure there's more nuance to primary constructors, but that's the TLDR version. So back to the slides. So that's all from C# 12 that I'm going to touch on today. So I'm going to have a look at some of the new APIs now. So the first one is time provider. So .NET historically hasn't had a good way to do testability with time, because we've had datetime.now, datetime.utc now. Lots of people, including myself previously, have done things like adopt node time just to get iClock, so we can test around the clock. But now with .NET 8, and this is also supported down level through a name of the package I've forgotten the name of, not just built into the framework. So through NuGet, you can get this from a package as well, so you don't have to update to .NET 8 to use the time provider. And that has support for getting the current time in the local time zone, UTC. You can also get a timestamp, so if you're just measuring how long did something take, rather than take a timestamp, take the exact current date and time, you can just take a timestamp, which is a long, and then you can take another long later, and then there's an API whose name I've forgotten. I think it's on stopwatch maybe. You just give it the two numbers and it will tell you the time span that is the duration between the two. And as well, Microsoft are also shipping a fake implementation of it, so you don't also have to write your own test mock. And then the other thing I'm going to touch on, mainly because I've helped work on this a little bit. So there's also a new suite of resilience libraries. So I'm sure a lot of you have heard of Poly, but now the .NET teams have done some investments to build some, what they're calling their resiliency libraries that build on top of Poly. So Poly gives you retry, timeout, circuit breaker, all of those sorts of things. But you have to read the documentation to make sure you configure them in the way that actually solves the problems you're not trying to solve. Because I'm a maintainer of Poly and I still forget which order you have to put them in the pipeline so that they apply in the right order, and I always end up reading the docs. The Microsoft teams have built a bunch of extensions on top of Poly that they've also made it do the sensible defaults. So potentially with one line of code, you can make all your HTTP calls much more resilient, but also do what's probably in the 95% case, probably what you would have configured it to do anyway. So you don't have to put any brain power into it. You just go, make that more resilient. One line of code, done. So we'll come on to that. So back to Visual Studio. So primary constructors be gone. So I've written throwaway demo code. Payday calculator, is it payday? If you just use datetime.utc now, you'd have a very tough time testing the implementation of this, because your tests are either going to pass one day of the year, one day of the month, or they're going to fail every other day of the month. And you probably don't want to just YOLO it. People get angry when they don't get paid. So in this class here, we're taking a time provider, hello primary constructors, and then the default implementation with no parameters. The baked in default is time provider.system. So that is the real clock. So in my is it payday stupid implementation, I just use time provider.get UTC now to get the current time, turn that into a date time to get today, and then I just do what probably not financially sound code to work out, is it the last weekday of the month and should I pay everyone? So if we just nip along to the tests, which I'm not going to run, that's boring. Well, I'm going to run one in a minute. So we can now, to test that, we can use the fake time provider class, which is in a separate package, which is available on NuGet, and I can tell it what time to be. So based on my implementation, these days are not days anyone should get paid. So I can just put the date in, call is it payday, and I get the appropriate Boolean parameter that shows that I'm not paying anyone on those days. And then similarly, I can test that these are all the last Fridays of the month in 2023, so they should all be payday. The thing to take into account with the fake time provider is it's about the flow of time. It's about the currently thought to be immutable fact that time moves forwards and does not go backwards. So you can't make time go backwards with the time provider for testing. I tried this for the demo, hit and then went, yeah, that doesn't work. So here, the fake time provider can also automatically increment. So if you've got some code that's just running in a loop going, is it Sunday, is it Sunday, is it Sunday? You can have it automatically increment by a period of time as it goes along, but by default it's frozen, it's just always the same time. But so what I can do here is it's not payday on the 29th of November, but then I can add a day. So I advance the time provider by 1 day. So it now is payday. And then I advance it again. It's now the 1st of December, so it's not payday anymore. Oh, yeah, and then, so if you set the auto advance amount property, then that will automatically do that for you. So that simplifies the test above. So I just call is it payday 3 times and it goes false, true, false. And I don't have to manually increment the current time by a day to get that behavior. It also works with the local date and time. So insert arbitrary for the lols demo that harks back to the future. So I can say that it's currently 1985 in Hill Valley, and then I can time travel 30 years into the future because I can't go back, which unfortunately means we need to go to Back to the Future 2. And then the other feature of the time provider, which I forgot to mention at the top, is it also interacts with timers. So within .NET you can create timers, so you can do things like tell me about this thing in 2 hours, or every 1 minute run this callback, so you can effectively do like event handling. The framework in .NET 8, not in the other previous versions, it has parameters for certain APIs like task.delay that will accept a time provider. So that means you can make weird, quirky timer-based code deterministic, and it behaves the way you would expect it to. So in this case, I've created myself an egg timer. You say how long you want to time the egg for, and then I create a timer with a resolution of 1 second. So every second, it's going to see if the egg timer's up yet. And then once the egg is cooked, then it fires my callback and tells me how long the egg took to cook. Why you would write that code outside of a demo, who knows? So now I've got my test here. So I create my egg timer with a fake time provider. I say I want it to be runny because those are the best eggs. So it'll be 3 minutes. And then I take, for the purposes of the demo, I'm going to use the real clock to get the current time. And then when the egg is cooked, I'm going to take a note of the time that it actually is, and also the time that the egg timer told me the egg was cooking for. And then in the background, I'm just going to run a bit of code where I manually advance the timer forwards in increments of a minute. So as far as the egg timer is concerned, it will be 0 minutes, 1 minute, 2 minutes, 3 minutes, and that will take 3 minutes. So if I run this test now, dun, 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 live demo time. Oh, I'd already run it. Open test log. I'll just ignore the fact it was running. So the egg timer thinks it took 3 minutes to cook that egg, but actually it took 27 milliseconds, because that's how long the code that was running in the loop in the background that was doing the timer incrementing took to go through 3 minutes worth of a bit more time, a bit more time, a bit more time. So if for some reason you've got code that needs to go to sleep for an hour, if you use time provider, you can test it actually waits for an hour as far as the time provider is concerned, and not sit there spinning in your chair waiting for the test to pass after an hour. So back to the slides. So brief interlude in AOT. So I mentioned AOT before at the top. So AOT is about trying to make your application smaller and faster. Some of the things it does is it removes just-in-time compilation, so you're no longer paying for the JIT to interpret your IL of your compiled code to work out what it needs to actually execute on the CPU for the instruction set you're running on. But that comes at a cost. It removes runtime code generation, so if you're doing like IL emit and things like that, those no longer work at runtime. You also can't load plugins, so if you've got a huge suite of plugins for whatever your software is, those won't work anymore, because part of what the things AOT does is it analyzes your program and it removes all the types and code that you're not actually using, because its goal is to make everything smaller. So if you're not using it, why do you need it? I'll throw that out. And that's why things like plugins don't work, because, well, if I'm not doing reflection, I'll just remove all the reflection stuff. And now you can't load your plugins because you need reflection to do that. And one of the use cases for that sort of thing is JSON serialization. Lots of JSON serializers do runtime reflection-y type stuff, so it can deserialize and serialize your types. And all of that stuff stops working with AOT. But you want to use AOT for your cloud-native applications, and lots of cloud-native applications do JSON things. So it's kind of like, well, I want to do that, but I can't do that. What's going on here? And source generators are a really great way to solve that problem, so you can have your cake and mostly eat it as well. Which brings me on to the two new source generators as a concept, sorry. If you're not familiar with what source generator is, it's a feature of the Roslyn compiler, and it provides a way for at compilation time for code you've written to run and interfere with the compilation result and potentially create more compilation results. So it's not a code generator in that you run something and it spits out some files and then you compile your code. It compiles code while you're compiling your code, which can create a bit of a meta sort of thing. But existing use cases for that include the JSON source generator and the regex source generator that was new in .NET 7, which is really good because they put so much work into having the source generator output comments explaining what it's doing. So the old adage, you used regex, now you've got two problems. Well, now you've got slightly less of a second problem because it's at least got documented source code telling you what it's trying to do. And then sometimes that might lead you to go, that's not what the regex is supposed to do. So the benefits of source generators is they move more runtime cost from when you're starting your app up to compile time, which means your app starts up faster so you can scale faster. And that's great for situations like AOT, where the whole point is you want to get everything started as quickly as possible by not doing as much startup stuff. So that's where the two new source generators I'm going to, cover come from. So there's, I got confused with my own slides. I thought I had slides for that and I did not. So there's two new source generators in .NET 8. There's the configuration binding source generator and there's the request delegate generator. The configuration binding generator, if you're using iOptions and you've got your JSON files and you put configuration into it and it all gets bound into objects, that all gets turned into compile time stuff and it will generate all the code for that for you. And then the request delegate generator, if you've used minimal APIs, the way that works when it was introduced in .NET 7, it uses all that IL emit stuff. So it emits code at runtime that maps what the framework needs to do into what your API handling method does. So the request delegate generator turns that into a source generator. So that's all done up front for you. So the thing you can't do with the native AOT, which is IL emit, isn't a problem anymore because it's not doing it because it's all baked into your app already. So if I go to my program, so here I've got a weather options, which just has some properties on it that get read out of JSON. And then I'm calling configure weather options here. It looks like that's going to call this method, which is the normal method that exists. However, this is where C# interceptors come into play. So if I just open the Solution Explorer, dig into the analyzers, where's the right one? Extensions, I think it's that one. Yes, sorry, configuration binding source generator. And then I can see the source it's generated. It's got this intercepts location attribute. And then it's got this intercepts location. And then it's got the path to my code. And it says line 17. So I go back to the code, line 17. The compiler is basically, the source generator is generating some code that the compiler will do some black magic. So when this method gets called, it won't call that method that IntelliSense has got. It will instead call this method, and this is the source generated code that does all my configuration binding. And then the same applies to the HTTP methods. So I'll just open that over there. So I've got my my method here that's doing weather forecast. It's calling an API, then it's doing some JSON. The generated code for that stitches all of the bits from my code to the ASP.NET Core framework together for me, so that that all magically works at compile time, so that when I run this app in a native AOT environment, it works, even though that all the technologies that originally make minimal APIs work aren't available. So the reason I mention these source generators isn't because, oh my God, native AOT, isn't it great? Because it's not finished yet. Because if you've got any UI, if you use MVC, you use Razor Pages, you use anything like that in your ASP.NET Core app, you can't use native AOT today because they've not yet done the work to make those technologies AOT friendly. But if you do have those components, you can still benefit from improving your startup time a bit because you can still opt into the source generators and move all that stuff to compile time. So even though you can't have the whole Kool-Aid of the native AOT experience, you can have a tiny little sip and make your application just a little bit faster. And when you're running at really big scale, that can add up into your AWS, your Azure, your Google Cloud bill, and then over hundreds of servers, that can add up to savings you will actually notice in terms of either hosting costs or startup time. And every little bit matters when you're deploying to the cloud, because there's a lot of stuff there. So I think these are the last two things. So the final two things I'm going to mention are new features in the .NET SDK. So there's artifacts output, which makes where your stuff that you're compiling goes and publishing a lot more predictable. And also the terminal logger, which makes working out what the hell it's done a lot simpler. So it's time for some animated GIFs. This one's quite boring. Artifacts output. If I don't use it, you get something similar to this, which I'm sure you've seen hundreds of times, where the structure is like all the way down to wherever your CS project file is, and then there's a bin folder, and it's got a release, and then it's got your target framework, and then it's possibly publish, and then you've got that repeated for every project you're compiling. If we enable the artifacts output, which you can do with the MS Build property use artifacts output equals true. I'm not going to have you parse that, but it is genuinely different. But in summary, it's now being all dumped out here. So there's now a folder called artifacts, and that has bin, obj, publish in it, and then that has sensibly all your projects, and then release, debug. And if you target multiple TFMs, then within that it will also have net 8, net 7, net 6, whatever it is. There'd also be debug there if you were doing debug. But it means if you've got a complicated build system set up, it's a lot easier to find the stuff you actually need to put in your Artifactory storage place, or the website you actually need to deploy somewhere, because it's not just all wherever it happens to be. And it also means that all developers on your local machines, it's all going to be in the same place as it is on the build server. So you don't end up with that, oh no, in the build server we override where the output goes, and now all your scripting doesn't work. Same consistent experience. The other benefit of that is when your disk's running low, which happened to me the other day, you can just delete the artifacts folder. You don't have to go through your whole structure and go delete all the bins, delete all the obj. I could have used tree size, or I could have scripted it, but it's a lot easier to just delete that one folder with shift delete and delete it with couldn't think of the word then. Terminal logger. I'm sure you've seen this. You compile some code, it spits out a load of stuff, and then ideally it'll get to the end and go done. Or you make a mistake and then you get a load of red showing at you. With the new terminal logger, which you can turn on either with the MS Build terminal logger environment variable or the new --TL switch, instead you get this, which is a lot more compact, and there's some colors. And also you get a nice running timer on how long everything took. And in the case where there's an error, I should have sped up the animations. You get one error. You don't get, there was an error, but where was it? And also, at least with that sample, I've not tested it to death, it stops when there's an error. It doesn't keep going and then, oh, why did it fail? Scroll, 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 scroll. Oh, that's what I did wrong. So I think that's a nice little improvement for the just local developer experience. At the moment, it's opt-in, so you have to set the environment variable to auto, or you specify the flag. The reason it's auto is because if you try and turn this on in a CI environment where the output is redirected, you're probably going to make your build probably take about 5 hours to run, as every time it backtracks, it does a new line. And then you're going to end up with horrendously massive build logs and very slow builds. So it's opt-in, but it tries to auto-detect if it should be doing it. But I think that's a nice little feature that just sort of makes it a little better to actually build the software in the first place. So that was everything I was going to cover today. If you want to read up about the stuff I've talked about, or the stuff I didn't talk about, either because there isn't the time in the world or because I don't know anything about it whatsoever, like Blazor. So there's links here to the different Microsoft documentation for what's new in .NET 8, resilience libraries, which I realise I forgot to talk about. I'm going to very quickly do a one-liner in the middle of the outro, just to point it out.
So just all the links here, you're going to share the PDFs of the slides, so we'll stick those online along with the recording.
Yeah.
So you can click all the orange bits.
Yes.
Yeah.
So one-liner, add standards resilience handler. Boom, you've got Poly in your app. There's also a load of talks from .NET Conf on these topics and more. There's loads of great ones. I haven't watched many of them because I've just not had the time, but there's so much stuff there. Link to the samples, obligatory socials, and that's it. And a QR code which will take you to GitHub to the slide deck if you want it. Thank you very much.
All right. Do we have any questions? Got a lot of enthusiastic people getting QR code. That's not the Rickroll QR code now, is it?
That would have been funny, but no.
Yes.
Yeah, one question. Do you know if the HTTP client resilience libraries require a .NET upgrade, or is it a NuGet package?
If I'm remembering correctly, you do not need to upgrade because they've down-leveled it to net standard and other things. And also because Poly it's built on top of Poly, and Poly works on .NET Framework and net standard and some other things. There might be a few things like related to time provider maybe that don't light up if you're not on .NET 8, but as far as I'm aware, you don't have to upgrade to .NET 8 to use it.
Cool. Yes, so much.
From out of all the updates, which one you're really, really, really excited about, basically, that would be really useful for, let's say, to progress
So, weirdly, I think it was primary constructors, because with a lot of the new C# features, there are code fixes if you're using Visual Studio. Apologies to anyone using another IDE, I don't know if they have them.
They do.
In Visual Studio, there's like fix all in solution and fix all in project. And I did fix all in project on my test projects where I was doing things like passing iTest output helper into my test classes. And I just went fix it all. And I've got a pull request somewhere. I'll try and remember to send the link later for the other links. I deleted about 500 lines of code from a project just by doing use primary constructors. And I think that really tidied up the test code base and made the mechanics of XUnit get out of the way of the tests so that you could focus on what the tests were trying to do rather than all of the boilerplate to just be able to do some logging and stuff like that. So considering the input of effort my input effort was fix everything, git commit, go. Apologies to anyone who reviewed that PR. Loads of lines, it's fine. But that one was weirdly very low ceremony. I thought big benefit for readability and maintainability, even if it's not necessarily exciting.
Can I add another answer to that one? So for me, the thing about the AOT stuff that's really exciting is for the first time ever, you will be able to write something in .NET and compile it to an executable that you can give to someone and they can run it without installing .NET. Because it will actually, as long as you're not using reflection, and it's difficult because you pull in a bunch of packages from NuGet. If any one of them is using any reflection anywhere, you don't get to play. But if you're building command line utilities, you're building little tools, diagnostic tools, networking tools, build it in .NET, you can AOT compile it, you can get a native executable, and then you can be like, yeah, just download it and run it. You don't need to install .NET Framework or .NET Runtime or .NET Core or .NET anything. And that's something I think I've been waiting for since like 2002. So that's quite cool.
Downside of that, if you maintain a library, there's a good chance sometime in the next year someone's going to knock on your door and go, this doesn't work in native AOT. And then you've got some work to do.
How many of you folks out there have got something up on NuGet or GitHub that is .NET and it's open source and everyone's using it and it's got reflection in it? Yeah.
Top tip, if you do maintain a library, update to the .NET 8 SDK, and then I think it's publish AOT is the property, and if it's not that, there's another similarly named property. Add that into your build scripting and see if it says anything. And if it doesn't, you're good to go. And if you're creating something new, set that at the outset, because then you won't accidentally introduce something that's not native AOT compatible later, if that's something you want to support. A lot of the libraries I maintain are test related. test frameworks need reflection. No one's AOTing that stuff. There's no reason to, and if they do, that's weird.
All right. Thank you, Martin.
Thank you very much.